Hello, students. Good to see y'all. So I'm going to be doing a quick video on solving an equation with more than two steps. And I realize right now we're not actually solving for y, so let me fix that. We are solving for x. There we go. Okay, so we have this equation here. 3x minus 4 plus 3 plus 2x equals 4. Whew, that is a long equation. And I'm actually going to start off by writing this equation with tiles. And I think you'll see why in just a minute. So 1, 2, 3 x's, then 1, 2, 3, 4 negative units. 1, 2, oh, there we go. 3 positive units. And then 2 x's. Interesting. When you put the tiles out here, it actually looks a little simpler because it doesn't seem like it's a 3x plus a 2x. It's just 5 x's. And that makes sense because this is a positive 3x. That's a positive 2x. So we can add those together and get 5x. That would be combining like terms that are on the same side of the equation. And similarly, with our units here, we notice, hopefully, that there are some zero pairs. We can use the zap box to cross them out, and we're left with this -1, and that becomes a much easier equation to solve. So I'm actually going to start by writing this equation here. 3x, let me zoom in so it's not as annoying to write this. 3x minus 4 plus 3 plus 2x, just got it in there, although it does look a bit fuzzy, sorry about that, equals 4, and that's our given. Okay, so now what I'm going to do is I'm going to do algebraically what I did with tiles. I combined my like terms. I took my 3x's and my 2x's, combined them together because they're on the same side of the equation, on the same mat, and that's 5x. I made zero pairs with my unit terms because they're on the same side of the equation, okay? And so that would give me, well, this would be 5x. Oh, I'm using the wrong color. Let me get green for combined like terms. There we go. 5x. And you don't have to. I like to circle, square, triangle my like terms. So I'm going to circle my x's. And then I'm going to box or rectangle in my units so I can tell these are like terms and these are like terms, okay? So now I have just 5x minus 1 on mat A, and I've got 4 on mat B, okay? So I'm going to write CLT for my justification. And what that stands for is combine like terms. And that's exactly what we did here. We combined the like terms that were on the same side of the equation. And now this looks like a much smaller and more manageable equation. We can see that we've got our variable term over here on mat A, and it's on the same side as our units. And we can tell that there are multiple x's on mat A. So that tells us we need to both use the additive inverse and the multiplicative inverse. So really quick, I'm going to show us that with tiles. And I need to, I'm so sorry I forgot, I need to bring over my 4 units for mat B. There we go, these 4 units here. I forgot to get them in the beginning. Sorry about that. And I want to figure out the value of just one x, but before I do that, I need to get rid of this -1, and I do that with additive inverse. Remember, additive inverse is where you add the opposite of a constant to both sides of the equation to eliminate that term. And not just any constant, it's a constant on the same side as the variable. So the opposite of -1 is +1. So I'm going to add a +1, and because these sides are equal, that's why we have the equal sign here, I'm going to add a +1 to both sides because I'm treating both sides equally. So if I add a +1 to mat A, to make this zero pair, I have to add a +1 to mat B. And algebraically, what that would look like is I would just be adding 1 to both sides, because again, I want to get rid of this -1 so I can have my x term isolated. I can make my x term alone. That makes a zero pair. And then what I'm left with is 5x on mat A. We can see that 5x right here, that's all we have on mat A because we got our zero pairs here. They're nothing. And on mat B, well, I've got 4 plus 1. And you could use a calculator, but that would be 5. And the last thing we need to do is write our justification. So I'm going to write AI for additive inverse. Don't stress about trying to write the whole thing here because that'd be a lot. But if I were letting you type this or if you were handwriting this, then I would want you to write additive inverse. Okay. Now the last step that we need to do is we need to find the value of 1x. And we can do that by making a giant 1, also known as dividing by the coefficient. Okay, you can see if I divide mat A by 5, that becomes a giant 1 because 5 divided by 5, that means 5 split into 5 equal groups equals 1. And so that would give me just 1x on mat A. How I would show that with tiles is I would use my grouping boxes. Now, unfortunately, there's only 4 grouping boxes, so the last one we're just going to pretend it has its own grouping box, but the other ones you can see, when I break them into their 5 equal groups on mat A, they all have an X tile, and on mat B, they all have a 1s tile, which basically shows us that X equals 1. We can see that for each of our groups. And remember, this one, we're pretending it has its own grouping box. Well, here, since I divided mat A by 5, I have to divide mat B by 5. And when I do that, well, that's also a giant 1. And so that tells me that X equals 1. Okay, and the last thing we would need to do is put our justification right here. Multiplicative inverse, I'm just writing MI. And then lastly, we would need to write solution. Okay. I hope that this video was helpful. If you have any questions, please let me know. And keep up the great work, everyone. Bye.